right, welcome grade 10s back to a video on trigonometry, and I realized I jumped into trig and the students were asking, ma'am, can you just make a video of the basics of trig? So this is as if you've never really attended a class on any trigonometry. We're going back to basics where I'm going to teach you from scratch how to address the trig ratios, sine, cosine, tangent, then also, starting at what do we know about a triangle, a right angle triangle, how to convert that over and using that to calculate different sides or an angle size that has been asked. So I'm going to wing it from the get-go. The only thing I've got here is my back to basics and a right angle triangle. Okay, so if we had to start, what do we know about a triangle? What have we learned about, not just any triangle, a right angle triangle up to now in grade 8 and grade 9? We've learned that if you have a right angle triangle, we hopefully know that the opposite is called the hypotenuse. The opposite to the 90 degrees, the hypotenuse. And hopefully we've learned that if you take this side, I'm just going to call it 4 centimeters. This one represents 3 centimeters. And if you take the two sides and you square it, add it together. So the two shorter sides, which is the two sides always touching the 90 degrees. So it's those two added together, squared, gives you the hypotenuse squared. Okay, and then we've also learned about the triangular triplets, the Pythagorean triplets, 3, 4, 5, 6, 8, 10, 14, 15, I'm just trying to think now, 14, 15 squared, 15 squared minus 14 squared, I think it's 14 or is it 13? No, it's 15, 13, 15. Anyway, there's a few that gives you nice whole answers. And those are the ones we call the Pythagorean triplets. Okay, so very important, we've learned that whenever you use Pythagoras, my kids are losing marks here and there because they don't write Pythagoras. So please, very important, even if you just say Pyth short, you have to say Pythagoras. Okay, so we've learned that if you take the two sides squared, add it together, gives you the hypotenuse squared. And here you can just go to write h is either plus minus 5. So that's very important. It's coming in now that that you have to use the plus and the minus. So why is that? I'm just going to tell you, perhaps if you didn't know. So 3 squared plus 4 squared gives you 25. Is equal to h squared. And if you square root both sides, up to now, maybe your teacher has introduced it to you, you would just say h is 5 because the square root of 25, and if you square the square root, that will cancel out and you get that it is 5. But very, very important. We have to start noting now, you are grade 10, that we have to say that it's either a positive or a negative 5. Okay, why is that? Because if I take 5 and I square it, I get 25. But if I replace a negative 5 and I square it, I also get 25. So your answer is always a positive or a negative and that number. Okay, in this case, if we were talking about distance, then you would say, well, distance is always positive, so I'm going to say h is 5. Okay, now, in trigonometry, we have brought in now, so in grade 10, we brought in trigonometry, where we're going to look at how to work with a right angle triangle by either finding, if I had to draw you quickly, I can either give you a side and an angle, let's say that was 26 degrees, and then you can find another side. Or we can give you a side, and we can ask you to work out the angle. So we can either give you two sides, asking an angle size, or we can give you a side and an angle and asking you to work out the other side. Okay, so let me quickly summarize that for you, and then we're going to take it from there. All right, so as you can see here, I've written up our two triangles. I've got two triangles, two right angle triangles, and I've got scenario 1 and scenario 2. So please, for this part, please have your calculator at hand so that if you need to punch it in with us so that you can do so and see that you get the right answer. Okay, so now in grade 10, we've learned that you can actually work out the angle size. So we bring in the angle size together in ratio with the sides that it is representing. So with that, we always have a little rhyme that we remember. And I'm sure your teacher has taught you this. I'm just going to write it down. So we never write sine by itself. So sine theta, sine beta, the signs for an angle size that we represent an angle size with is either theta, beta, or alpha. We like to use either these two. It's just, we could have said sine x as well, but because we are already using x and y's and things, we there's actually three signs, that we like to use to represent an angle size. So don't get scared when you see this. It is just a representative of an angle size that we don't know how big that size is. Okay, so your teacher, hopefully, if you can remember now, it's a sin to say opposite over the hypotenuse, cos to go and see aha, cos to go and see aha, and tan theta is equal to or are the person tanning. Okay, so however you remember this, lots of people say so ka toa, Sokotoa, Sokotoa. Lots of people say, oh, heck. So if you just write down sine, cosine, tangent, then you say, oh, heck, I wrote another A there, hour of algebra. All right, so however you want to remember, but please, these trig ratios you have to know off by heart, and you cannot afford to make any mistakes with them. All right, so how do we name our sides according to that angle we are working from? So it all depends on what angle you are looking from. So in this triangle, we are working with this 30 degrees. Okay, so now they are asking you to calculate x. So we need to see what do we have and what do we want from this angle size. So if you had to label these sides from your 30 degrees, this would be your opposite. The hypotenuse is always across the 90 degrees, so your hypotenuse. And then third side, it's easy to label those two. The third side then is your adjacent, so that's the one that is left. Okay, so in this case, we need to know which trig ratio we're going to use. Okay, if you look here, we have the hypotenuse and we want the adjacent. So we're going to use, I encircled the x there, but we want the adjacent. So aha, that is what we want. So can you see the only trig ratio here that has an A and an H is cos. Okay, so cos, I'm going to write that in. Now that theta represents the angle size, which is 30 degrees. Cos theta is equal to r, the adjacent, which is x, over ha, the 15. All right, and now my maths is going to take over, so I'm just going to rewrite it here. Cos 30 degrees is equal to x over 15. So both sides, we want to find x. What is happening to x? It's being divided by 15. So I'm going to times with 15 on both sides, because x over 15 times 15 over 1 will almost cancel out. And you've just got x left. I'm going to take that away again. All right, and then you're just going to pop that into your calculator, 15 cos 30, and then you're going to get s to the d, that x is equal to 12.99 centimeters. If that's given to you in centimeters, yes. So it's that centimeters. Depending on the rounding off, then you would do that. Okay, I hope that makes sense. Let's quickly look at if I had to change the x and I am looking for this side over there. So I'm asking you calculate AB. If I had to label it like that, AB represents x. So now which trig ratio are we going to use? We've got the opposite over the hypotenuse. Or it's sine theta is equal to opposite over hypotenuse. So I'm just going to do it over here. So if you had to find AB now, which is x, so you're going to say sine 30 degrees is equal to the opposite, which is x, over the hypotenuse, which is 15. And then again, you're just going to times both sides. Times both sides with 15, and then 15 sine in your calculator 30, and it gives you 7.5. Okay, so now let's have a look. If I am giving you, I'm going to take away the 15 because I just want to show you the maths behind it. And I say to you, let's say this one over here was, let's make it something that we've worked out already. Opposite. Okay, let's say this is 13. All right. So now what are we looking for? Sorry, I'm running out of colors here. So let's say we are still looking for x over there. So now we are working with the opposite and the adjacent. And OR is tan. So tan 30 degrees. Can you see here? Opposite over the adjacent. So tan 30 is equal to the opposite. Now I'm looking for something else. We can do this one. Okay, tan is equal to the opposite, which is x over the adjacent. So 13 tan 30 is equal to x. So x is equal to 13 times tan 30. And that gives you s to the d 7.5 centimeters. So do you see you get the same as this answer over here because I used the same the same size over there, the same length. I'm just looking quickly which one to ask. I'm just going to quickly pause. All right, I just want to show you this type as well with the mathematics, the algebra behind it. So if we look at this, sorry, the other one was quite cluttered already. So if you work from this is the angle size that you're going to work with. That is the one you've got. And then you are looking at the opposite and the hypotenuse. Okay, so this side over here will be the adjacent, but because there's nothing given, we don't know anything about it, we're not going to use it. Okay, and now you're going to say, which one has an O and an H in it? O, sine, yes, so sine 20 is equal to the opposite over the hypotenuse. All right, and this is where I just want to show you the algebra behind it. So we want to get x alone, but at the moment we can't because x is at the bottom there. So we're going to times each side. There's two ways of doing this. So I'll show you both ways, or a faster way. So you times by x on both sides to take away that fraction. Then you're going to divide away with sine 20 over here. And what you do on the one side, you have to do on the other side. So x is equal to 15 over sine 20. So 15 divided by sine 20. And that gives you that x there is 43.86 if you round it off correctly, centimeters. Okay, you can always check your hypotenuse must be the biggest size. So it has to be smaller than, bigger than 15, which it is. Okay, now my students, they like to do the maths behind it, and I just showed them this easy, a quick way of doing it. So if you know your distance, time, and speed, it will look like that. And then your teacher taught you speed is equal to distance divided by time, time is equal to distance divided by speed, and distance is equal to speed times by the time. Okay, now what we're going to do is we're going to apply that sort of mathematical operation in this. So we're going to have the 15 at the top. Whatever is in the top of the fraction goes into the top of your triangle, and then the other 2 is going in the 2 bottom parts. And with this, then you can easily see x is equal to 15 divided by sine 20. Okay, use it, don't use it. Later on in your mind's eye, you don't have to draw the triangle anymore because you just realize x is equal to 15 divided by sine 20. If you just want to remember that pattern as well, that's also an option. X is equal to the top minus the one on the left. All right, so that is scenario 1. I hope that helped a bit and that I didn't confuse you more with all this writing, and I hope that you can follow. All right, scenario 2 is actually quite easier. In this scenario, we are looking to find theta. We are looking to find an angle size. So in scenario 1, we tried to we had a size of an angle and we had a length of the triangle, and we were looking for the other side, the other length of a side. And then in scenario 2, we are looking for the angle size. All right. So again, from theta, depends on which angle you are working from. So from theta, we are not going to work with the opposite, but that's where the opposite is. We are working with the hypotenuse and the adjacent. So, cos to go and see, so cos theta. So if you look here, the only one with a and a is cos. So cos theta is equal to the adjacent. So very careful with this one. It's the adjacent, which is 12 over the hypotenuse, which is 15. All right. So now we can find theta's size. So theta is equal to, and this is where we have to use the inverse function in our calculator. So to get the answer for theta, we have to say shift on our calculator, shift cos. Then it will give me cos to the power -1, and you open it up. Then you're going to put in that ratio 12 over 15. So 12 over 15, which is going to give you that theta is equal to 36.87 degrees. Let's just round up to the nearest degree, 37 degrees. Okay, so that is what you're going to do in your calculator. Shift cos. So remember, whenever you are working out an angle size, you have to press the shift cos function. Okay, just quickly another one, 90 degrees. Let's say this one was 5. This one from this angle over here, let's say it was 31 degrees. And we are I mustn't give you the angle size. So let's call this beta, and this one, let's say 8. Okay, so now you're going to say, what are we working with? From this angle over here is called beta. So we've got the opposite, not the hypotenuse for now, because we've got nothing there represented there, and the adjacent. So OA is the tan function. Tan beta is equal to the opposite, which is opposite, yes, over the adjacent. So what are we going to press over here? We're going to press shift tan 8 over 5, and then we get rounded off 58 degrees. So that angle over there is going to be 58 degrees. Isn't that amazing? Just to know the trig ratios, we can work out an angle size or a length of a side just by using those trig ratios. Now, very important, I just want to quickly show you something. If you've got a triangle, let's say this side is represented by theta. Okay, they didn't give me the angle size. They did, however, give me 5 and 4 and 3. Let's say we knew all those ratios, we worked with Pythagoras, etc., and we could work it out. So now, if they ask you to work out, let's say, sine theta, what would sine theta's value be? So then you would say, okay, it's a sin to say O, which is 3 over 5. Okay, if they had to say cos theta, you would say cos to go and see ha, 4 over 5. And tan theta would give you, to do tan is opposite, which is 3. The opposite over the adjacent, which is 4. Okay, so now those are your trig ratios. Now, what if I ask you this? Tell me what is sine 90 minus theta? What is cos 90 degrees minus theta? And what is tan 90 degrees minus theta? Then the only thing I want to teach you from this is, what is this angle size if we represent it in terms of theta? So this side over here, can you see that it's going to be 180 minus 90 minus theta? Okay, so why? Because interior angles of a triangle add up to 180. So this side over here will be 180 minus 90 minus theta over there. Okay, so if you simplify that part, it will give you 90 minus theta. So this side that is always not given is that funny size that you're going to see, sine 90 minus theta, cos 90 minus theta, tan 90 minus theta. And what that means is you are just going to work from this angle here that represents 90 minus theta. So if I want to do the sine ratio value for this, you're going to work from this angle over here, and now you're going to say, well, the opposite from this angle is 4 over the hypotenuse, which stayed 5. Cos, to go and see so now the adjacent is 3 over the hypotenuse, which is 5, and tan is opposite over the adjacent, so 4 over 3. Okay, so can you see it's different too from this angle over here when we are working from this top angle over here. So that's why I'm sure the saying from, it all depends on what angle you are looking from. What angle are you looking from? I'm sure that comes from trigonometry. Okay, so it depends on what angle. So what is the value for sine 90 minus theta? Well, you say it all depends from which angle you're looking at. So now we're looking from the top angle, and now the opposite is 4, and the hypotenuse stayed 5, which is fine. Cos is the adjacent over here, over the hypotenuse, and tan is the opposite, which is 4, over the adjacent, which is 3. All right, so that is the basics with trigonometry. There's lots of questions. Maybe I'll do another video on how to do some of the questions that have that deals with real life situations where there's 2 triangles in one. Yeah, I think I'm going to stop here, and then I'm going to make another video on those types of questions. Okay, thank you so much for watching. I really hope that you've got trig down and that you are fine with it, because it's such a big part of your grade 10 syllabus, and it just continues. You never get rid of trig, so it stays with you all the way to matric. So please make sure that you understand these basic concepts that we are learning or teaching you in grade 10. Okay, have a great day. Bye.